And let me take you to practice quiz problem 1. And a note before the practice quiz. On the homework that you're going to be assigned today, which is 5.3, skip problems 24 and 27. So it doesn't say that in the homework sheet. So those two problems have to do with intermediate value theorem. When you read, use the intermediate value theorem and you say, well, I don't know what that is, that's a good memory device to like, oh yeah, those are the ones we're supposed to skip. Just those two problems. Otherwise, follow the entire assignment for 5.3. Alright, so find the x-intercepts, also called roots or zeros of these two functions a and b. Let me give you a minute on those. Also, exam number 2 is a week from today, next Tuesday, and before Thursday I'll be posting something that's kind of like a practice exam that you can use as you study and get ready for the exam on Tuesday. Okay, 30 seconds more. Alright, let's look at problem A. So, to find the x-intercepts, the procedure is we set the opposite letter y to 0. So we just replace this with 0, and then we solve it. Because, why do we set the y to be 0? Because x-intercepts are somewhere along the x-axis. The y-coordinate of a point is the height of that point. And its height has got to be 0. It can't be, if it's a positive number, it's up above the x-axis. If it's a negative number, it's below the x-axis. Only if it's height of 0 is it on the x-axis. So we take this and then we solve. Now I can bring the 12 the other side, but I can also solve it this way. If I bring the 12 to the other side and divide by 3, I'll get 4. But if I do it this way, you can just see two numbers multiply to be 0 only if one of those is 0. This number is stuck at 3. It can never be 0. What will cause this number to be 0 is when x is equal to 4. So that, now if you just said x equals 4, that's not a complete answer. The x-intercept, I want the 2 coordinates. We also know that the y-coordinate of that is 0. So the x-intercept is 4, 0 for this. It turns out this one is this line here, and it has a slope of 3, and it goes through here. Its x-intercept is right here when x is 4. And the next one, when it's already factored for us, we can tell what the x-coordinates, when you set this, the output to be 0, you know that -3, if the product of three numbers is 0, one of them has to be 0. -3 is stuck at -3. It's not a solution. In fact, we could divide both sides by -3 and that part of it just goes away. But if x equals -4, causes this parentheses to become 0, or if x equals 1, it causes what's in that parentheses to become 0. So the x-intercepts are -4, 0, and 1, 0. Two of them here. Alright. And for the feedback, let me grab something over here. Hang on a second. I want to use, I've been thinking about this feedback, the protocol for feedback. I want to make it a little bit different. Alright, I'll use this. Alright, so I was asking before for you to give me feedback on whether you got the problem right or not, and rating the quality of the review. And it's difficult to give me two kinds of feedback, so let's just focus on one. Rate the problem as a review activity. And so you give me one of these three numbers. And number 1, the problem was too easy, reviewing this type of problem is no longer necessary. So it means you can move on, Shankin. And number 2, the review reinforces the concepts and the procedures. You find that it's reinforcing, so it's helpful. And number 3, the review is giving me new insights. Oh, I see it a little more deeply now. I can see it a little bit better. And then I'm also going to ask you, besides giving me a number, 1, 2, or 3, also to write something each time. When possible, give some specifics. You might be putting something down that another student just really relates to, or it might really be informative for me, like, oh yeah, that's the challenging part. I never realized that's the part that, I should be paying more attention to as I teach. Okay, so give me some feedback on A and B. Everybody can give me a little feedback there. Type it up. You don't have to hit enter yet. And go ahead and hit enter. Okay. And let's go to C. Find the x-intercept again for part C. Let's put D up there as well. Find the x-intercept for both of those. Okay, 30 seconds more. So we set the y to be 0. We need to factor this. And if it was something that didn't factor, I would use the quadratic formula on it. The two numbers that multiply together have to be positive. So they have to be both positive or both negative. I want them both negative. 4 and 1 will give me the correct middle term. So x is equal to 4 or x is equal to 1. So the x-intercepts are 4, 0, and 1, 0. And this next one, it's easy to overlook one part of this next one. 0. 3, negative 2, and 1. These are all x-intercepts. And they all have y-coordinates of 0. This one is to the 4th power. And it's going to kind of make this thing more 0 than the others. But in a way, there's no such thing as making something more 0. So this is something that's strange with this 4th power. And we're going to get into that today. But for right now, it just gives you one more x-intercept. Okay. And give me a little feedback on C and D, please. And you can go ahead and hit enter. Okay, that's a helpful comment. Still need more practice. Okay. And, all right, let's go to number 2. State the end behavior of each of the following. Let me have you do A and B. Okay, and there's something else I need to tell you all. Now, there is not going to be any more spot checks. So when you're going to upload your homework, you're going to be thinking, oh my gosh, there's no place to upload the spot check. There is no more spot checks. It turns out there's a limitation inside of Canvas on how many assignments that I can have. And as I set up this course, I got full at around the halfway point. So somewhere around the halfway point, I need to stop. There's too many grades. Canvas won't accept that many. This juncture that we're at right now, I hope that you really take this to heart, as you've had the experience of what it's like that when an assignment is assigned, you have it done by the next day, so that you can ask questions, and then you can get the understanding that you have down at that point really cemented. And I hope that this experience in this first half will change the way you do other math classes, maybe even other classes in general, in all of your classes. You'll just get a lot more out of it if, instead of waiting till assignments are due, you get on them right away, and so you have a chance to really get the ideas down well and ask questions, and you got a whole process you can go through if you get on those assignments right away. And so the second half of this semester is going to give you the opportunity to exercise that muscle for yourself of giving yourself the self-discipline to keep the habit going. And then be mindful of this, as this is something that you may want to decide to do in other classes outside of here. So the structure is set up. It's kind of, maybe it's optimal this way anyway, so that you have a chance to not just, follow the requirements, but to now kind of set up a habit on your own of getting the stuff done beforehand. I'll give you another minute on this. Yes.
This is Beverly.
Hi, Beverly.
The spot checks are ending, and we will just homework, new project, will
Correct.
you still get a chance to redo any problems we get wrong on the assignment? Does that make sense?
Um,
Previous classes I have had,
yes, yes. If I'm marking something wrong, you can
it's
still
been
be
turned
redoing
in
those.
homework, and then we'll
Okay, Beverly, you're really chopped up.
you would.
I cannot hear what
We
you're saying, Beverly. I think you have such a bad connection. It would be better if you type it in the main Discord channel. Type in your comment or question there, and then I'll address it, but I can't make out what you're saying. Okay, and I'll come back to that after after you finish these and we go over these two, the end behavior. So let me give you just a little bit more time, another 30 seconds. Okay, so for A, you could do it like this. You could say, when x is really, really large, this whole thing is going to go. So on the far right, it's up. And on the far left, x is a huge negative number, it's down. Or you could say, on the far right, it's up. On the far left, it's down. And so that's the end behavior for A. And so on B, we have to visualize what this would be like if I FOILed this out. But I only have to visualize this much of it. The very first term is going to be negative 3x squared. The rest of the terms I don't care about. And that determines the end behavior. And when it's an even power, they both are up or both are down. And since it's a negative, they're both down. It's like this. Okay, so let me look at Beverly. If she's a ton of snow where I live, so my internet's really bad. My question was, even though the spot checks are over, will we still have the opportunity to redo the problems we've missed? And the answer is yes. When I give you feedback and say, these problems are wrong, you can redo them, and I'll give you a full 100% credit. And that's the objective with each of the homeworks, to get 100% credit. All right, and would y'all give me feedback on 2A and B? And go ahead and hit enter when you're ready. Alright. State the end behavior of the next two. C and D. And let me give you 30 more seconds. All right, on C. Leading coefficient determines the end behavior entirely, and it's positive coefficient. So when x is like 100, this will be huge. 100 squared is 10,000. That's way bigger than the negative 500. So you'd get positive over here. And when x is negative 100, you're still getting a positive result. So all the heights are going to be positive. And for this next one, we have to imagine that we've FOILed all this out. But that's not hard, because all we have to do is get the first term right. It's going to be negative 4, x to what power? There's 4, 5, 6, 7 x's. Now, it's got other things after that, but we don't care as far as end behavior goes. This tells us with an odd powers are normally up on the right and down on the left. But because it's negative, it's the opposite. Up on the left, down on the right. If x was a huge number like 1,000,000, this would be positive, but that would make it a negative. If x was negative 1,000,000, we'd get a double negative, making it positive. All right, a little feedback on C and D. And you go ahead and hit enter. Okay, some of these comments are helpful. Okay. The end behavior it's rather conceptual. It takes some time to get used to that. All right. Number 3, write the equation of the line that passes through those 2 points. Excuse me. Take 30 seconds more. Alright, and before I do this one, I'm going to just visualize it a little bit. 1 over, 1, 2, 3, 4, 5 up. 3 over, and 3 down. And then the line between those two here. So we're going to be asked to find the equation of this line. And to kind of be checking my work, see that it's reasonable, it should have a negative slope. Because like if I bought stock in this company, I'm losing money. And its y-intercept should be a very big positive number. All right. Bigger than 5. All right, so with that understanding, I'm going to go to first step is the slope. Difference in y's over the difference in x's. And then I can go to either y equals mx plus b or y minus y1 mx minus x1. Now, this second one is the quicker way. It's the way we mostly do these. But the first one kind of explains the idea, makes it a little bit more intuitive. Let me do both. And I can just substitute either point into this. Let's do this point slope formula first. We're going to take this 1 and put it in right here. And we're going to take the 5 and put that in right there. So then, and we're going to take the m is negative 4. So y minus, y minus 5 equals negative 4x minus 1. And y minus 5 is negative 4x plus 4. Add 5. Y equals negative 4x plus 9. And it meets those conditions that I had stated by looking at this graph. Has a negative slope and the y-intercept is above 5. Okay. Now we could have also done it this way. And this way is the only one thing that we know right now is that the slope is negative 4. Now the b is going to turn out to be 9, but we don't know that yet if we were doing it with this method first. Alright? But what we could do is the m and the b, if you know their roles, those are called constants. They never change. But the x and the y are variables. They get to play the what if game. If x is 1, the y is 5. And we could even plug in, let's just for kicks plug in the second point instead of the first one. Plug in 3 and negative 3. We could plug in either one. If we plugged in 1, 5, that would have been fine as well. And if we do that, I'm going to get, and I'm plugging, actually those arrows should be down here. Plugging them in down here. Negative 3 equals negative 4 times 3 plus b. Negative 3 is negative 12 plus b. Add 12. B is going to be 9. And then y equals negative 4x plus the b, which is 9. Either way, I get exactly the same equation. So, give me feedback on number 3. And go ahead and hit enter. Okay, it's good to know. Alright. Beverly, the video will be up this afternoon if you've got to wind up doing that. And that's it for the practice quiz problems. Questions now. Any questions, any homework, or anything else?
I have a question on number 25.
What section is that?
5.2.
5.2, 25. And you are?
Sasha.
Sasha. 5.2, 25. So let me get the right page here. So we're going to take 25, find the intercepts. So now, when it just says intercepts, it doesn't mean just the x-intercepts. It also wants the y-intercepts. So the x-intercepts are all the values of, they're not x, sorry, these are t-intercepts. All the values of t that will give us 0. And when t is equal to 1, when t is equal to negative 2, when t is equal to positive 3. Now, we could have also done these, and you might have done them in like prior classes by every time you set these to 0. And then you add 1, and then you add 1, and then you get t equal 1. But it's easier and quicker to just look at it and say, what value of t causes this to be 0? All right, so then these are all 0. And then there's always going to be just one y-intercept. How come there's always just one y-intercept? Because that happens when you set the x equals 0. Not the x, the t in this case. When you set the t equal to 0, you're going to get f of 0 equals 2 times negative 1, because 0 minus 1 is negative 1, times 2 times negative 3. And there's going to be two negatives, that makes positive. 4 times 3 is 12. So the y-intercept is really the point 0, 12. And of course, when you plug in t is 0, you're only going to get one answer. So that's why there's always just one y-intercept, and that's consistent with being a function. It said it was a function, and there's got to be just one output for each input. All right, Sasha, does that answer your question?
Yes, but in the book it says all real numbers, so that's why I was a little confused if I did it wrong or something, because it said all real numbers, so that's why I was confused.
Ooh,
When I
think you're
checked
wrong.
my answers back to the book.
5.2. Let me look at my back of my book and just see if it's also in all these books. 5.2, 25. No, mine has exactly what I have. Maybe it's just the online version.
Okay. Thank you.
You're welcome. Other questions?
Hi, Mr. Shankin.
Hey.
I had two questions from 5.2, numbers 42 and 62.
Right, let's start with 42. And your name is?
This is Vanessa.
Vanessa. Okay. So 42. We need the directions here, so let's get a snipping tool. Alright. For the following exercise, determine whether the graph of the function provided is the graph of a polynomial function. If so, determine the number of turning points in least possible degree. So this right here, these are called asymptotes. And polynomial functions do not have what's called vertical asymptotes like this. So this is not a polynomial function. Polynomial function. Okay. Polynomial functions, if it was going to the right like this, would have to go infinitely far to the right and infinitely far to the left, or something like this. We could have a third degree polynomial function, which looks kind of like this. But they do go infinitely far to the right. They don't have a barrier that you can't get beyond. What it means when there's a barrier you can't get beyond it is like, well, look at this. Suppose this was 1, 2, 3. At 3, there's no height to the function. So 3 is not even part of the domain. You can't put an input of 3. But if it's a polynomial, sure, x could be 3, and then we'd get an output. So if this is just squashed in between these two vertical lines and that's it, then it's not a polynomial function. Polynomial functions are kind of like this. There's an example. It's x to all these different powers, and you can plug in any value you want for x, and you'll get an output. So that's why it's not a polynomial. Good question, because that's really different than the usual. All right, what was the other one, Vanessa?
Sorry, just to clarify, so there would be no turning point and no degree?
Oh, well, determine whether the graph, if so, if it is a polynomial function, then you determine the turning points, but only if it is a function. So you don't have to answer those for that. And it doesn't really have a turning point because it doesn't change from increasing to decreasing. And then you can't have a degree with this. Okay. Yes?
Okay, sorry, thank you. My second question was number 62.
Okay. All right. For the following exercises, you use the information about the graph of a polynomial function to determine the function. Assume the leading coefficient is 1, or -1, and then there may be more than one correct answer. All right, so we'll look at 62. The y-intercept is 0, 9. So we're going to come up with an equation. And we know we got to get the y-intercept to eventually be 0, 9. Now what does that tell me? It tells me there's going to be a plus 9 way back here. Or if it's in factored form, that's if it's not in factored form. So for instance, if it had x to the 5th plus x to the 4th plus something x to the cubed and so on, when x is 0, all those x parts are just going to get zeroed out, and it would have to be 9. But if it's in factored form, then it would look a bit more like this other one that we were doing when we found the y-intercept of this one. You have to plug in the 0 in, and then these would have to all multiply out to be 9. Then the x-intercepts, now it's going to be actually not in factored form. It says the x-intercepts are -3 and 0. Now when an x-intercept is -3, that tells me that that is a factor. Because when I put -3 in for x, it causes the y to become 0. And it also is 3, 0. That's a factor. Now the degree of the polynomial is 2. So if you FOILed this out, you would get a second degree. The end behavior as x goes to negative infinity, f of x goes to negative infinity, So it's telling you that it goes like this. On the far left, you're going down. And on the far right, you're also going down. So this tells me that this coefficient out here, if the leading coefficient was either 1 or -1, it had to have been -1. We don't even have to write the 1 to make this to be a downward parabola. Right here. Vanessa, does that answer your question for 62, or is it still kind of unclear?
I think you answered it.
All right.
Mr. Kim?
Yeah.
I also have a third question. So yesterday when I was trying to figure out what was due today with spot checks, the syllabus said that it was 5.2 and 5.3 spot check, and my calendar said it was 5.2 and 6.2 spot check, or 6.3 spot check. And then I checked the class recording from last time, and you just said to do 5.2. So in the future, which should we follow the calendar or should we follow the syllabus?
Whoa, they should not be disagreeing. So I'm going to make myself a note. If they're disagreeing, I'll fix it so that they all agree. And if there is ever a conflict, you look in OneNotes and see, you know, what I assigned the section or something like that. But there shouldn't be any more of those. I'm going to make a note here. And after class today, I'll look so you're talking about probably inside the modules there's a schedule. And then the due dates for, so it said for today on the schedule, it says due today is just 5.2 on our schedule, the spot check for 5.2. And then I think I wrote the spot checks into the schedule, even though there's no place to upload them, so that if you want to just, you know, stay up to date with the same pattern that you were in before. Okay, and then you're saying when we get into here, the modules, homework 5.2 is due the 29th. That seems right.
No, I was talking about the calendar, and the calendar on like the side and the calendar on the syllabus didn't match.
Tell me where you're finding these. If where is the calendar? Where do I find the calendar that you're talking about?
On that blue strip on the side, it says calendar.
Okay, that calendar. I'm not used to this. Okay, so this gets filled out automatically. And it's, right. So it's saying, so today, seems to be a mess. It has a whole bunch of things. Oh, crossed out means we've already done that. So today is the 27th of October? I don't know how to read this. So I would not trust this calendar. It's not something that I've put in. This is what Canvas does automatically. Okay? All right, anything else? Any other questions? Then let's take a 15-minute break. So we will start again. At 1:32 p.m. And does anybody need to talk to me before I take my break? All right, see you in a bit. Okay. right, we are starting up again. And, oh, on this last problem that we had done, 62, notice that it said the y-intercept is 0, 9. When I started writing out in non-factored form, it would look like this. And when I did it, well, this, having the x-intercepts kind of forced me into putting it into factored form. But the only choice I had out here was making that positive or negative 1, since it says the leading coefficient is 1 or negative 1. And then we were forced into putting it negative, and then it just kind of checks that if x is 0, you'll get negative 3 times negative 3, which will be positive 9. And the y-intercept works out correct. All right, we're going to go today to graphs of polynomial functions. We've been looking at graphs, but we haven't really been constructing the graphs. We're going to create the graphs, and we need a little more terminology to get us started. So, first picture here is we call this touching the x-intercept. Over here is crossing the x-intercept. So, if we kind of were thinking if we were whipping around here, we crossed the x-intercept because we were above it, and then all of a sudden we're below it. So we crossed over it. And then the next time we hit the x-intercept, we were below it. We just touched it. We never went above it. So we never crossed over to the other side. So we just touched the x-intercept. And then the last x-intercept, we were below it, and then we crossed over to being above it. Crossing the x-intercept versus touching. All right. Now, the next concept, multiplicity. If I have this function, now this, when I imagine foiling it out, and I would say, oh, there's 2, 3, 4 x's, so it's a 4th degree polynomial with leading coefficient that's positive. Now, the zeros, also called x-intercepts or roots of the polynomial, are the values of x that will cause y to be 0. And so when x is 3, or when x is 2, or when x is 1, they will all cause the f of x to be 0. But this is the new idea, the multiplicity of the 0. These two are what we call multiplicity 1, and it corresponds with this unwritten 1 exponent here and here. And this has an exponent of 2 on its 0, so it's of multiplicity 2. So the exponent, when you rewrite it in exponent form, the exponent would be the multiplicity corresponding to that 0. All right. Now, we're going to create graphs for each of the following. We're going to pay attention to crossing or touching the x-axis and the multiplicity of the zeros. And I'm going to be doing this, and after I'm doing this, I'm going to ask you in your groups this question. So let's just straighten out with the groups first. Make sure, because we have how many people? 19 people in 6 groups. So go into your group and say hi. Group leader, make sure your group knows who the spokesman for the day is in the group. And let's just do a check-in with each group. All right, group 1, how many of you are here today? Group 2?
Oh, we're all here.
How many is that?
4.
4? Okay. Group 2, there's 4. Group 3, how many?
Just one.
Just 1. All right. Group 4, how many? Nobody from group 4? Group 5, how many?
2 of us.
2 2 of you. And group 6, how many?
There's 2 of us.
2 of you. All right.
There's 2 of us in group 1. Sorry about that.
No problem. 2 of you in group 1. All right. So, the one person that's in group 3, I want you to join group 5. So, go into group 5, unmute that channel, and say hi in that group so they know who you are and that you're a part of it. And let me do the same thing. Group 1, I'm going to send you to group 6. So.
Now we have 3. Sorry about that. There's somebody that responded now.
In group 1?
Yes.
And there's 3 of you. Okay, so you stay in group 1 and we'll leave all the groups the way they are then. All right. And, all right. Let's go back to this. All right, so y equals x squared. What I'm going to do is draw the picture. We all know that y equals x squared looks like this. But what we want to pay careful attention to is, do we cross or do we touch on our x-intercept? This is a touch. Because we were above the x-axis and then we stayed above the x-axis. We never crossed over to the bottom side of the x-axis. Y equals x cubed. That one looks, we've gone over what these basic polynomial functions look like. It rises up steeper than this one does. And it would be a parabola going like this, except when x is negative, you're also going to get a negative result. So this one crosses the x-axis. Y equals x to the 4th. It's like the x squared, except it rises up faster. Both of them going up. Once again, it touches. Y equals x to the 5th. Y equals x to the 5th looks very much like y equals x cubed, except it rises more steeply. So it's going to be kind of like, I just kind of screwed up right at the end there. Let me see. So it's like this graph, but just going up faster and down faster. And once again, this crosses. Okay. How does multiplicity? Now, you might think, well, this doesn't have anything to do with multiplicity. Well, yeah, it does. Let's go back to these. Y equals x squared is the same as 0 is an x-intercept of this, and its multiplicity is 2. 0 is a multiplicity. 0 is an x-intercept of this one, and its multiplicity is 3, and so on. So the question is, how does multiplicity affect the graph at the x-intercept? And I want you to type your answers into your group chat, but don't type them in yet. I mean, type them in now, but don't hit enter yet. So work on it individually first. And go ahead and hit enter. And you can discuss this. Okay, group 2. How does the multiplicity affect the graph at the x-intercept?
It will determine whether the line will touch the axis or cross it. So it'll determine the shape of the graph in a way.
Very good. It determines whether cross or touch for the x-intercept. Okay, now that's an excellent start. Can we add anything more to this? Can we say something about when it's a cross and when it's a touch? And I'll open up the floor to anybody. Anybody. When is it a cross and when is it a touch?
I think when it's even and when it's odd determines when it touches one.
Which one, even or odd, does what?
I think even means that it touches and odd means that it crosses.
So touch is when you have an even multiplicity. And cross happens at an odd multiplicity. Okay. And that seemed to be consistent with the data. Whenever it was even, 2, 4, we were touching. When it was odd, we were crossing. This is true. And let me give you a little insight into why this happens. Why does it cross on an odd multiplicity? And why does it touch on an even multiplicity? Well, let's look at these again to see this. If I write y equals x squared as this, and if I think of making a table, and I'm moving from over here to the right, I'm putting things like -3, -2, -1. I'm plugging them in here. Now what happens in each one of these, I'm going to get 9 when I square -3. But I'm not going to write 9. I'm going to write what I'm focusing on. I'm going to get a positive number. When I plug in -2, I'm going to be above the x-axis, another positive number. When I plug in -1, I'm going to be a positive number. Okay, now if I plug in -0.1, when I take -0.1 times -0.1, it causes this to be negative and this to be negative. Two negatives multiply to be a positive. Now, when I jump over the x-intercept, some of these signs will change. When I jump to the other side of the x-intercept, and I'm now at positive 0.1, it will change this. plug in 0.1 and I'll get a positive up here. And then this one will also be positive. But it'll cause an even number of sign changes. And when an even number of sign changes happens, we stay the same sign. So as we jumped from here to here, this causes an even number of sign changes. In y, in the function. The negative goes to positive, but two of those happened. Okay, now whenever we have an odd power of multiplicity, so I'm going to rewrite this one as y equals x minus 0 5 times. 3, 4, 5 times. Okay, and if I was making an xy table over here, I'm just going to focus on these two. Because if I put in a whole bunch of negative numbers, I'm going to always get negative answers. And even if I plug in negative 0.1, I get what? All these are negative. Plug in negative 0.1 for the x, and you get a negative times a negative times a negative times a negative. 5 negatives will give you a negative result. When you jump over the x-intercept, which is 0, and you go to the other side, 0.1. Oops. I want to put this in red to 0.1. So we've jumped to the other side. Now when you plug in 0.1, it causes this to change sign, this to change sign. All of these will change sign. And then, how many signs changed? If it was just 4 signs changed, it would still have the same sign. But since it's 5 sign changes, see, because 4 negatives multiplied together would be negative, but this, and then it changes to positive. So as we crossed from here to here, oops. 1, 2, 3. 4, 5. Yeah, we have an odd number of sign changes, and that causes this to actually change sign instead of stay the same sign. Okay. And all right. That has to do with odd and even and multiplicity, how it affects the multiplicity. All right, so we kind of summarize it here: cross, odd multiplicity, and this. And this is the multiplicity of the x-intercept. Let me even kind of make that real clear in here. Multiplicity of the x-intercept. Affect the graph at the x-intercept. Okay. Now let's come to here. Theorem. For polynomial function, if the multiplicity of a 0 is blank, then the graph blanks the x-axis. And then if the multiplicity of a 0 is blank, then the graph blanks the x-axis. Fill in all 4 blanks. And I'm going to give you a minute to work on this on your own. And then you're going to be typing it into your group chat. So you can type it in now, but don't hit enter yet into your group chat. Okay, go ahead and type it in your group chat. Group 6, what do you got?
We have that if the multiplicity of a 0 is even, then the graph touches the x-axis. And if the multiplicity of a 0 is odd, then it crosses the x-axis.
Okay. Now, what it means to be a theorem in math is that they've proven that this is true. So we can use this as a fact from now on. We know this is always going to be true. All right. So now we're going to go to graphing a pretty complicated function. F of x, look at this. This is kind of a pretty complex function. To graph this, we will do the following. A will determine the end behavior of this thing. And then we will complete the x-intercepts table with zeros and their multiplicity, and we'll say T or C in this last row. T for touch, C for cross. Okay. So let me give you a little bit of time to determine both the end behavior and to make your own little x-intercept table. Now, it's going to be easy to type in the end behavior because you could say far right, up or down, so on. So type that into your group chats. For the x-intercepts table, you might have to say, just kind of summarize the results. This x-intercept, it touches or crosses, and so on. So, keep working it on your own for a little bit more, but type in your results, but don't hit enter yet. Okay, go ahead and hit enter. Discuss it briefly. All right, group 1. What's the end behavior of this function? Group 1, you got anything? You can always pass.
I think I know the best.
I couldn't understand that. Did you say pass?
Yes.
Okay. All right. Let's go to group 5. You got anything for the end behavior?
I think we'll pass too.
Okay, this one's tricky. Anybody? Anybody have
We said that just for the end behavior,
Yeah,
both sides will go up.
both sides go up. And why is that?
Because if you try and find the leading term, you can basically count the number of x's that there will be, and so there's going to be 4. It's going to be 2x to the 4th, because
Excellent.
yeah.
Okay, so it's even power. Even power, they either both go up or both go down for the leading coefficient, and they're both going up. So this one is in behavior with positive is both going up. Okay. Complete the table of x-intercepts with multiplicity. And let me go to group 2 for this. Group 2, do you have anything?
Can we pass?
You bet. Okay. Anybody? I'll open it up again. Complete the x-intercepts table. Okay, let me do it.
Shouldn't the zeros be x is equal to 3, x is equal to 2, and x is equal to 1?
That's right. All the ones that would cause the y to be 0.
And then the multiplicity would be 2 and then 1, 1.
Very good, because you just look at the exponents associated with those.
And then wouldn't they cross?
For this, well, when it's even multiplicity, let's go back. Multiplicity is even, it touches. Even, again, was when, look at all these even powers. They didn't touch it.
Makes sense.
Yeah, and
I
it
missed that.
causes an even number of sign changes. Yeah, so we get...
So then it would be touch and then cross.
Very good.
Cool.
All right, is this Verity that I was just speaking to? Or who
No,
was it?
it's Destiny.
Destiny. Oh, that's right. Destiny. Okay. Then let's go to part C. Determine the y-intercept. So I'm going to just leave you with part C now. So I'm going to give you a minute. Well, actually, we're kind of running late on time. So let me do this part. Determine the y-intercept. We set x equal to 0. And when you set the x equal to 0, you're going to get f of 0 equals 2 times negative 3 squared, you just plug it in, times negative 2 times negative 1. Now negative 3 squared is 9. And then you're going to get 2 negatives making a positive here. So you're going to get 9 times 4, which is 36. Okay. So, but that's not the total answer. You got to put them together. The x was 0, the y was 36. That's the y-intercept. All right.
I thought you were supposed to put 0 where negative 3 is, where negative 2 is, and where negative 1 is. Or it's not like that?
That's for the x-intercepts. for the x-intercepts, what value of x is going to cause just what you were saying, the x minus 3 to become 0, and that's 3. And the x minus 2 to become 0, that's 2, so on. For the y-intercept, it's simpler, but sometimes it takes longer to compute it because you actually got to multiply things out. We set the x equal to 0, and then every one of these x's gets replaced with 0 now. It goes in here,
Okay, thank you.
and here. All right. Well, not in that first one. I did that wrong. Point at the x. Those three become 0, and that's how we get all this. Glad you brought that up and clarified that. Okay, now we got the y-intercept. We have all the x-intercepts and their multiplicity. Actually, we don't really need the multiplicities. We just need to know whether they touch or cross. We use the multiplicity to help us figure out touching or crossing. And we have the end behavior. With all that information, we can now do the sketch of the graph. And how do we sketch this graph? All right, so, well, I need to have my graph go up 36 high to have a y-intercept of 36. And I just need 1, 2, and 3 along the x-axis. So when I sketch this out, it's going to be one, 2, and 3 along the x-axis. Not far. But the y-axis, I need to go all the way up to 36. So I'm going to go by 10s here. 10. You don't have to go by the same scale. In fact, you never fit them in if you did by the same scale. .36 is going to be somewhere up here. And then these, we're going to be touching or crossing each one of these, and we are going to be hitting this. And we're going to have this end behavior. So, on the very far left and on the very far right, we know it goes up. We know it comes through this y-intercept. Now, when I come down to hitting 1, I'm either going to come and just nick it, which will be touching it, or I'm going to cross over it. Which one? I'm going to go to blue, and I'm going to put a little T or C next to each one of those. 1 and 2 are C's. I said crossing. 1 and 2, so next to these, I'm going to put these little blue C's to remember to cross. And at this one, I'm going to be touching. 1 and 2 crossing at when x is 3, you touch. Alright, so now I'm going to go back to my red color. When I do this, I come here. I don't come back up. That would be touching. I have to cross to the other side. And then I gotta loop around. And that's the only way I can cross here. Now, should I have gone way down and up? Turns out it doesn't matter. All we're going to be interested in is, are you on the correct side of the x-axis all the time? Are you above it when you're supposed to be above it? And are you below it when you're supposed to be below it? We come up to here. Now, we're going to have to come up and then come down, but just touch over here. We might come way up and come down, or we might just go up a little ways. It doesn't matter. You can have artistic freedom. What you want, the main thing though, is we want to make sure that we don't cross over. If I did this, that's not correct, because I crossed over. I have to do touching it. Just touches it. And then I go like this. Okay. And then, when I'm done, I could take this function and type it in to a graphing utility. And I'm going to show you one now. It's my favorite. It's called wolframalpha.com. And this is 2x minus 3 squared, so I got to remember that function. So I'm going to go to Wolfram Alpha. I've used this so many times, it's popping up, .com. Now, Wolfram Alpha is better than a graphing calculator because it's got a natural language interpreter. It'll try, you don't have to learn any way to do it. You can just, I could type the word graph, but it'll do a number of things. If I just put a function in, x minus 3, up arrow for squaring, times x minus 2 times x minus 1. And I'm going to hit enter. And then it puts it in a nice, easy to see that, yeah, that's what I meant. And then it tries to do a whole bunch of things with it. And this is the shape that it came up with. On the far left, it was going up. It's kind of like a W shape. And on the far right, it's going up as well. And then it, blows up for, a certain region. But this graph is what we really want. And how does that relate to my picture? I have this kind of a W too. It doesn't have to be exact, precise at all, but when we're supposed to be above or below the x-axis, we have that right. And we have the x-intercepts right. And we have one key point to y-intercept. Correct. Let me go back to Wolfram Alpha. The only thing that looks different, this doesn't go all the way to 0. This is over at 1. If I wanted to, I could say from x equals 0 to x equals 4, something like this. Wolfram Alpha is kind of, you just type what you think it'll interpret right, and it usually will. And so this, you can kind of see that we're still doing it. It's kind of like our shape, but it's going to hit it way up high. So x equals 36, or y equals 36 for the y-intercept seems reasonable. All right, now let's go to another type of problem. Number 5. We're going to create a possible function from the graph. And this one, I'm going to look at this and I'm going to say, x-intercept. Well, there's one at -3, and there's one at -1, and there's one at 3. And then, remember, it was multiplicity and then touch or cross. we can look at these and say, oh, it's crossing, it's crossing, and it's crossing. All three of these. Now, what is the multiplicity? Well, it would have to be odd. We're going to make this as simple as we can make it. What's the smallest odd number I can think of? Is 1. 1, 1. And so then, now, I'm going to, my end behavior, notice the end behavior. On the far left, it's up. On the far right, it's down. Possible function for this. Negative 3 is a 0, so negative 3, when you plug it in, it causes this to become 0. Negative 1 is a 0, so x minus a negative 1 or x plus 1 would have to be a factor. And then 3 is a 0, so x minus 3 would cause that. Now, if I just left it like this, I would have those intercepts correct, and they'd all be touching. But this one is a third degree polynomial, and its natural end behavior is this. But this one is opposite. The far right it goes down, and the far left it goes up. What does that mean? It means we have to make it a negative coefficient. And we'll make it the smallest possible number we can think of, 1, there. And so this is a possible, the easiest graph I can think of that would work to satisfy this. And we've got it right here. Okay, so one other one, because this one, I could say, oh, it's only got 2 x-intercepts. When x is equal to what? Negative 1. And when x is equal to negative 1, it touches. So it must have, oh, not odd, even multiplicity. And then look at the other one. X equals 2. There it crosses. So it must have odd multiplicity. Alright, now its end behavior is on the far left it's going up, far right it's going down. What could a function like this be? Well, for x equals negative 1 to be an x-intercept, it must have had x plus 1. So negative 1 causes that to be 0. Or in other words, it's x minus that number, x minus a negative 1. And the other one had to be x minus 2, so that when you plug in 2, it causes the line to be 0. And this, though, there's 2 things wrong with this. This is only if we stopped here. This would be a parabola, both up or both down. Also, it would cross on both, because these both have odd multiplicity. This one, at negative 1, it touches, so we need, because it touches, we need this even exponent. When it crosses, odd exponent will be doing just fine. Now we have a third degree polynomial, so that's great, because this is third degree, not a parabola. But this one would have, third degree polynomials tend to have that end behavior. The only way to reverse it is to put a negative coefficient. And that would do it right here. So there's how we'd create such a function. Alright, so the homework. Is 5.3 we'll stop here for today. Any questions or comments? Yes, odd numbers, cross, even, touch. And what helps me remember that is think of y equals x squared. Y equals x squared, touches. Visualize that, even, touches. All right, we'll stop here. I'll see you all on Thursday.
Bye. Thank you.
You're welcome.